today we are going to chat radicals, not only just by themselves like we have here, but also in solving by roots. So the first thing I would suggest doing, if you have a color, this might work a little better. If you don't have access to a color, even though I have them up here, draw a box around these numbers, draw a bubble around them, don't really care which. But the reason I want to do this is these are our magic numbers. Our magic numbers for breaking down radicals, which I'm going to talk more about here in a moment. But I always want to make sure people understand it's these numbers, not the squared numbers that I'm looking at when I'm trying to figure out what I'm doing with these. So you're like, okay, what exactly are you doing with these? Good question. And here's the answer. We're going to get a couple of things jotted down here along the edge. So here's the deal. I need two numbers that multiply together to equal the number under the radical. You're like, okay, that doesn't seem too difficult. So like, if I wanted to use, for an example, even though we're not doing it yet, if I wanted to do the square root of 90, you're like 9 times 10, 45 times 2. There's a whole bunch of numbers I can use. So I have lots of options. That would be true most of the time. However, always has to be that but in there. But one of the numbers has to be a perfect square. In other words, it has to be a number in the list that we highlighted. So if when I was trying to figure out before my two numbers to get to 90, and I played with the calculator and I got 2 and 45, 2 and 45 wouldn't help me because 2 is not in the list and 45 isn't either. At least one of your numbers has to be in that highlighted list in green, or that you bubbled around, or whatever it happens to be. So, the suggestion that I always give to people when they're trying to break down a radical is this. For instance, if you're looking at example 1, which is a good place to start because it's the first one, and you're not sure which numbers may go in, I always suggest grabbing your calculator and trying to stay where I'm not covering up what I've written. Well, I'm going to come back to it. And I just start dividing the biggest one that will go in, and I start working my way down. Now, if I get a decimal, it means it doesn't go in. And so I may try for a bit. Some of them I may know aren't going to go in, so I really don't need to try them. But once I find that first one, okay, that biggest one. So 9 times 10 is 90, which is important for my purposes here. So 9 and 10. And the reason that's important is one of them breaks down. Now, I tell a little story along with these to try and help it catch a little bit better. Sometimes it works, sometimes it doesn't. The perfect square, these are both in radical jail. The perfect square on good behavior gets out with a new identity. 3. Square root of 9 is 3. However, 10 is still acting irrationally. So 10 has to stay in radical jail. Okay? The perfect square gets out, the non-perfect square stays in. And that's how these work. Now, are there some details that can change up a little as we go? A little bit. A little bit. And example 2 is one of those times. So we look, we're like 48. Is 48 a perfect square? I already know since I have a list it isn't, but I'll double check. Okay, it isn't. No. I need to divide in. Now, sometimes I will have people say, hey, I know. 4 goes into that. It's 4 and 12. Here's the problem. We're going to make one more little note here. Get the largest perfect square. Well, why is that important? Excuse me. If I don't get the largest one, then I'm going to have to do it twice. Who wants to do it twice? I don't want to do it twice. So, when I'm looking at 48, again, if I'm not sure which number in the list I think is going to divide into 48 evenly, find the next largest number that will still go in. And again, start playing. And what you're going to find out is, hey, there is one that's bigger than 4. $16 and 3. And so again, the perfect square gets out of radical jail with its new identity. The non-perfect square has to stay under. So just about every time, that's how these are going to work. Find the biggest perfect square, find the 2 numbers, break the perfect one down. You're done. But of course, there always has to be a little bit of weird. So I give you example 3. So you're looking at example 3, and you're like, wait a minute, what's this number doing out here? We're going to ignore that until we're done breaking down the radical. So then you get 64, and you go to your list, you're like, wait a minute, 64 is in the list. Okay, square root of 64 is 8. So it's just 8. Not the square root of 8, it was in the list, so it's just 8. What about the 5? Multiply it times the 8. Weird. We went from a radical to like no radical at all because of what was there. So yeah, if your number under the radical is in the list, just break it down, you're done. And that one's finished. So then the last one, same thing again. 162, not in my list. Let me pull this down for at least a moment so we can see the other numbers. And so if I'm not sure, I start busting out my calculator again. And I start with the first number that's less than 162. Whoa, got to hit divide though, Hardy. There we go. And I'm going to keep going until, let me move to this side quick. Until I find one that goes in nice. 81 and 2 works. So, let me get this back up here. So 81 is perfect. 81 is on the list. There it is. 81 and 2. 81, perfect square, gets out of radical jail. 2, not so much. Okay? So that's going to be part of what we're doing today in the regular lesson. In a piece of it, we're going to be solving for x. So, long term, okay, I'll explain how we're going to do the assignment part of this in a bit, but I wanted to make sure this was a main part of what you were doing. So, keep this handy. We're going to want this as we're looking at the next part. But we're going to go in the packet now. Back here, I pulled the wrong page up to start, so just a moment. we're going to use that over here on page 25 in the packet to do our actual lesson on solving quadratic equations by finding square roots. Now, the nice thing is, with what we just did, I don't think we need to go crazy and do 5 more of these. I do want to do number 4, though, because what happens sometime if you run into a fraction that you're doing a radical for? You're like, ew, that's gross. Here's how we're going to handle that. When you run into one of those, you are always free to break the radical into pieces. Take the fraction and bust it into 2 individual ones. Because then that can be kind of nice. Because if I take a peek then, I'm like, hey, 4 is in the list. That's 2. Hey, 9 is in the list. That's 3. And I'm done. So don't let the fact that it's a fraction freak you out. That's not going to be a bad thing either. So, how do we actually use this? Okay, this radical thing, besides having this cool little way to break things down. Solve the equation, equals, okay. Remember, x squared usually means 2 answers. Ooh, that's kind of weird. We're going to add a little something in here, okay. When we're solving these, we're going to do 2 things. Step 1, is to get my x squared term alone. Now in number 6 it already is, but in number 7 and 8 when we get there it's not. We're going to have a little bit of work to do. Once we get x squared by itself, then we're going to take the square root, and this is the step where we're going to get plus minus in. That's going to require our 2 answers. Now that may seem a little strange on its own, but once we actually do this first one, it should make it a whole lot easier to be able to see what we mean by that and why it would be important to get both of our solutions. So, as we said on number 6, get x squared alone. Okay, it's alone already. So now what? We're going to take the square root. And I did that on purpose. The square root cancels the squared. So I like to give it the line right through the squared there, which just gets me x. Whenever you take the square root, the other side automatically gets plus minus at that term. Okay, at that point. And if the radical breaks down, and it does, the square root of 16 is 4. That one's done. You're like, no, wait. Why would you have to put plus minus there? Isn't the square root of 16 just 4? Here's my answer. While it's true that 4 squared is 16, we know that, isn't it also true that if I put it in parentheses, negative 4 squared, negative times negative, is positive? It is. That's why we put plus and minus on these. There's 2 answers. So just something to keep track of as you're rolling along. But these next 2, we're going to have to do a little more work. Because we need to work on getting our x squared term by itself first. So, how do I undo minus 3? Plus 3 or positive 3? Absolutely. Now, we still don't have x squared completely alone. We're getting there, though. How do I undo the multiply by 2? I know. So if we divide that, now my x squared is alone. Step 1 is complete. It's at this point, I'm going to take my square root again, which cancels my squared, plus minus. Now, 12 is not in my green part, my perfect square part. So, it doesn't mean I'm done necessarily. Again, look at your numbers that are less than 12. Ooh, 2, where'd 2 come from? 12 does not, 9 does not go into 12, but it does 4, 4 and 3. So, one last job. 4 and 3, and again, I always have colors up here if that would help. The square root of 4 is perfect. It gets out of radical jail. 3 is not on my list. It is irrational. It does not get out of radical jail. And I get to my answer. So you can see where our breaking down radicals comes in handy when we're trying to get exact answers, which is exactly what we're doing here. And so as we get to our last regular one here, again, keep stressing. X squared term alone first. Whatever is being done to it, do the opposite. We've got to keep thinking opposites on all of these. So here, I'm dividing x squared by 5. The opposite would be to multiply. Whatever we do to one side, we got to do to both. Now we're to the magical step again. X squared by itself. I do my square root. Oh, I didn't make it go through. Bad Hardy. And so again, I take out my list and I start dividing those numbers that are less than 35 in. And I'm like decimal, 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 decimal. 1 doesn't really do us any good. I've tried them all and they're all decimals. So then what? Well, after I put my plus minus that I almost forgot, this time the radical doesn't break down at all. That's the best I can do. And I'm done. So sometimes it breaks down perfect like it did in 6. Sometimes it breaks down a little like it did in 7. Sometimes it don't break down at all like it does in 8. So you can see a little bit of all of those. The last twist, one last one, is when our x ends up inside parentheses. That's a whole different game. When that happens, my first goal is to get the set of parentheses alone. So, multiplying something by a third, I don't want to distribute it, is the same as dividing by 3. So to get rid of it, if there's a situation like this, we're going to multiply by whatever the denominator is. That's going to wipe this out. And that's all it does. So I'm left with my parentheses here. And 7 times 3 on the other side. Now I wish at this point I could just subtract 5. That'd be cool. I can't though. This is stuck in parentheses. The next thing in my way is that squared. And we've seen when I want to get rid of the squared, I square root. You're like, ooh, it's not even the last step yet. Nope. So the x squared, the squared is gone. The plus minus is now here. And I need to test out to see if I can break down 21 at all, because it's not anywhere in my list. And so as I try them out, 16 doesn't work. 9 doesn't work. 4 doesn't work. Those are the only 3 that are usable, because again, 1 doesn't really help. So that doesn't get anything done. You're like, okay. And I'm trying to get x alone. Well, I got to take out this plus 5. Okay. Here's the tricky part. This is not in radical jail. This is. They cannot be combined. This is not 16. That plus minus is our buffer between what was already there and what's coming. I don't put the minus 5 over here. I don't combine it in. This just gets written first with the plus minus. That's as far as you can go. It looks weird. It looks undone. It's not. Okay? And so just one more to see, and then I'll get down to business on what we're going to look at as far as an assignment would go. One more time here. Get this alone. What am I doing to it? I'm multiplying it by 5. What's the opposite? We're going to divide by 5. $125 divided by 5 is 25. And we're in a situation, real similar to what we were on number 9. The squared is the next thing in my way. Square root that squared out of there. The square root step is always my plus minus step. And hey, we got lucky. The square root of 25 is a perfect square. It's 5, not the square root of 5. If it's perfect, we get out of radical jail on good behavior. So, plain old 5. Like, okay. Get x alone, opposite of that. Yep. So this time, since it's not in radical jail, can I just put it here and call it 6? No. We're still going to set it up that same way, but this time I can do one more step because there's no radical. I can do 1 plus 5, which is 6. I can get that done. And I can do 1 minus 5, which is negative 4. Because, again, there's no radical. If there's a radical, I can't do that. And that kind of covers this for what's going on as far as these